Dear students, in our previous class we have discussed about the De Morgan's theorems, and by two ways every De Morgan's theorem we have proved and we got the result. Now today we are going to discuss about the applications of De Morgan's theorem. So what are the applications of De Morgan's theorem? Now we are going to discuss. So applications of De Morgan's theorem. These are very important applications regarding De Morgan's theorem. You need to remember this. In that, the first application is De Morgan's theorem. De Morgan's theorem is useful in the manipulation of basic gate operations with alternative gates particularly available for De Morgan's theorem is useful in the manipulation of basic gate operations with alternative gates, particularly with NAND and NOR gate. Particularly with NAND and NOR gates, which are readily available in IC form. Okay, see, this is the first application of De Morgan's theorem. That is, De Morgan's theorem is useful in the manipulation of basic gate operations. Okay, basic gate operations like AND, OR, and NOT with alternative gates, with some of its alternative gates, particularly with NAND and NOR gates. Okay, in our next topics, in our next chapter, we will discuss about NAND and NOR gate. Then you will come to understand what is NAND gate and what is NOR gate. Okay, particularly with NAND and NOR gates, which are readily available in IC form. IC form means integrated circuits. You have already know that IC means integrated circuits. So this De Morgan's theorem is very helpful in the manipulation of gates which are readily present in the integrated circuit form. The next thing is De Morgan's theorem. De Morgan's theorem is used in the simplification of Boolean expressions. Okay, if any Boolean expression is there, so we will use De Morgan's theorem to bring this Boolean expression in simplified form. Okay, so De Morgan's theorem is used in the simplification of Boolean expressions. Okay, first you remember these applications, then after that when we move for deriving expressions, at that time you will come to know all the uses of and all the applications of De Morgan's theorem. Okay, it is useful in the manipulation of basic gate operations with alternative gates. Okay, particularly with NAND and NOR gate, which are readily available in IC form. The next point is De Morgan's theorem is useful in the simplification of Boolean expressions. Okay, next thing. Come to the third point. What the third point states? Third point states that De Morgan's laws, okay, commonly apply to text searching, to text searching using Boolean operations, and or and not. Okay, listen here. De Morgan's laws, okay, commonly apply to text searching. Okay, if you want to search any text, at that time De Morgan's law will apply. Okay, with the help of, okay, Boolean operations like and, or, and not operations. Next example. Consider a set of documents containing the words. Okay, this is, we are taking an example. Okay, consider a set of documents containing the words. Okay, a set of document is there which contains two words. One is Boolean. Okay, the next one is algebra. Boolean and algebra. Okay, so for this, if you want to search this thing, okay, if you want to search Boolean or algebra, then at that time De Morgan's law holds that okay, these two searches, these two searches will return the same set of documents, Okay, what this mean? Here, De Morgan's law commonly apply to text searching. If you want to search any text, at that time De Morgan's law will be applied with the help of Boolean operations. Okay, which are the Boolean operations? And, or, and not. So here we will take one example. Consider a set of documents. A document set is there containing the words Boolean and algebra. Two words. Boolean is one word and algebra is one word. At that time, okay, if we search these two things, Boolean or algebra, At that time, De Morgan's law will return to the set of documents. Okay, will return to the set of documents which are containing these two words. Okay, if you want to search any of these words, then at that time, what De Morgan's law will do? De Morgan's law will go to the set of documents, okay, which are containing either Boolean or algebra. It will go to that set of documents and it will search the words. And the last point. The last point is De Morgan's laws. De Morgan's laws are example for are an example for more general concept of mathematical duality. Look here. What is principle of duality? Okay, from any set of Boolean relation, we can create one more Boolean relation. In other words, it can be said as, okay, from starting of a Boolean relation, another Boolean relation can be created. So that is called principle of duality. Okay, here De Morgan's laws are an example for more general concept of mathematical duality. Principle of duality. What are the rules of principle of duality? First thing is change every and sign to or sign, and change every or sign to and sign. The next thing is change every 0 to 1 and change every 1 to 0. Okay, these are the main 2 points of principle of duality. When we do these two things, then we will come to an expression that is in the form of duality form. So this De Morgan's laws, okay, they are very much useful in mathematical duality. So for that thing, De Morgan's laws are taken as an example for mathematical duality. Hope you have understood this. There are mainly 4 points in the application of De Morgan's theorem. The first point states that De Morgan's theorem is very useful in manipulating basic gates operations, okay, with alternative gates, okay, with alternative gates. Then what type of alternative gates? Particularly NAND and NOR gates, which are readily available in the form of ICs, in the IC form, that is called integrated circuit form. And the next second point, what the De Morgan's theorem states, De Morgan's theorems are very much useful in simplifying the Boolean expressions. And the third point is here, De Morgan's theorems are very much used. De Morgan's laws are commonly applied to text searching. Okay, text searching with the help of Boolean operations like and, or, and not. For example, if you take any two words, if you take a set of documents, okay, in that set of documents contains any two words like Boolean or algebra. Okay, if we search Boolean and algebra, at that time, the De Morgan's theorem will go to that set of documents in search of these two words and it will give you the result. The last point is De Morgan's theorem is an example for, okay, more general concept of mathematical duality, as you have know that principle of duality. Okay, for that purpose, this De Morgan's theorem is very much suited. Okay, hope you have understood this. Next, come to basic duality of Boolean algebra. Basic duality of Boolean algebra. Okay, okay. Just now we have discussed about the principle of duality. Change every and sign to or sign to and sign. Okay, then change every 0 to 1 and every 1 to 0. Okay, this is principle of duality. So now we have to use this principle of duality for some of the theorems or the laws of Boolean algebra, which we have previously discussed, just like, okay, idempotence law, involution law, absorption law, distributive law, then commutative law, associative law. Okay, all these laws, regarding all these laws, if we try to apply the principle of duality, then it will be most useful and we can create these theorems by applying the principle of duality, or we can apply the principle of duality for all these laws. Now some examples I will take and I will use the duality and I will change those laws in its dual form, in their dual form. Hope you will understand after when I change these laws into their dual form. The first thing I will take a, okay, x into xy is equal to x. X into xy is equal to x. What is the principle of duality? Change every and sign to or sign. Okay, one and sign is here and one more and sign is here. Okay, change every or sign to and sign. Okay, there is, this is x plus xy. Okay, x plus xy is equal to x. Change every or sign to and sign. Change every and sign to or sign. Here there are no zeros and no one, so this will be equal to, okay, x. Okay, here or sign is there, we have to change it for and. Okay, then x, here and sign is there, we have to change it for or, and keep y as it is, which is equal to x. Like this we have to create the dual form of any expression. Here or sign is there, so we have taken it as and sign. Here and sign is there, so we have changed it to or sign. Okay, the next one, x plus y plus z. Okay, associative law. Then x plus y plus z. Now change this into its dual form, which is equal to, okay, write down x. What is there? Or sign is there. Change it to and sign. Okay, into y. Take y as it is. Okay, or sign is there. Change to and sign. Then write z, which is equal to. Okay, here x is there. Write down x. Okay, or sign is there. Change it to and sign. Write down y. Okay, here or sign is there. Change it to and sign. Just write the z. Like this, we have to change every expression into its dual form. That is called as basic duality of Boolean algebra. We have to change the Boolean algebraic laws into their dual form. Now I will take some more example. Okay, now come. X into 0 is equal to x. X plus 0 is equal to x. X plus 0 is equal to x. Which one is this? Properties of zeros and 1. In that, this is the first property. Okay. Now, what is the condition of Principle of duality. Write down x as it is, change or sign to and sign. Okay, change every 0 to 1, which is equal to x. This is also the principle of duality. This is also principle of duality. Okay, this is, what is this? Associative law. This is also associative law. Like this, we can do, or we can change any expression into its dual form. Now I will take one more example. So for your purpose, so you need to understand, for that thing I will take one more properties of zeros and one. X into x bar is equal to 0. X into x bar is equal to 0. Okay, write down x as it is. Then what we have to do? Change and sign to or sign plus. Then x bar take as it is, which is equal to, change every 0 to 1. Okay. So that you have to understand this. Okay. X into x bar is equal to 0. For that, change and sign to or sign and every 0 to 1. Now I will take some more examples for this. E. Okay. X plus y into x bar plus z bar into y bar plus z bar. So, how can we change this to its dual form? Okay, write down bracket as it is x. Okay, in place of or, we have to change it as and sign, x into y. Right? Okay, then here and is there, so we need to change this and sign to or sign, that is plus. Again, x bar, okay, plus is there, so what we have to do, change it to and, just write down z bar. Okay, here and is there, change it to or sign, plus, then again y bar here. This is finished. Okay, we have changed the and sign to or sign. Here y bar, okay, change this to and sign, so directly you can write z bar. So this is the dual form of an expression. So like this, we can create the dual form of any expression. So that is called basic duality of a Boolean algebra. Okay, so we shall move with next thing, derivation of Boolean expressions. Derivation of Boolean expression. Derivation of Boolean expression. So how can we derive the Boolean expression? Listen, just one thing is there here. Boolean expression which contains Boolean expression which contains a single variable, which contains a single variable or its complement, okay. For example, x, y, or z, okay, or x bar, y bar, or z bar, is called a literal, is called a literal. So this is most important for your examination point of view. You may get a question, what is a literal? Then at that time you have to explain in simple words any Boolean expression, okay, which contain a single variable or its component. Example, x, y, or z, or x bar, y bar, or z bar is called a literal. So I will show you with example. If you take x plus y as an expression, okay, in this x is a literal and y is also a literal. Okay, this is an expression, Boolean expression, which is containing a single variable. X is also a single variable, y is also a single variable. So this type of equation which containing single variables, and this, that is called as a literal. Okay, so before moving to Boolean expressions, okay, we need to discuss about before moving to derivation of Boolean expression, we need to discuss about basically two things. The first thing is the min term, okay, and the second one is the max term, min term and max term. Now we are going to discuss about these two things. What is min term and what is max term, and what are the things included under min term and what are the things included under max term. So now we are going to discuss about the min term. What is meant by min term? Min term means min term is a sum of all the literals, okay, all the literals with or without the bar, without the bar in the logic system, within the logic system. Within the logic system. Okay, look here. Min term is a sum of all the literals. So I will take here, okay, sum of all the literals. Sum of all the literals means we will take x plus y plus z. Okay. Sorry. Just a minute. Min term is a product of all the literals. Min term is a product of all the literals, not the sum of all the literals. It is a product of all the literals. Now I will take x into y into z, which is equal to, okay, x into y into z, what it will become? X, y, z. This is called as the min term. Min term is a product of all the literals with or without the bar within the logic system. So if I take, okay, x into, okay, y bar into z, x into y bar into z, then what is its min term? Its min term is x y bar z. It means it is the product of all the literals. Okay, so the product of all the literals within the logic system is called as the min term. So here one important thing is there. Now I'm going to write that important thing here. The most powerful, the most powerful theorems of Boolean algebra, Boolean algebra, okay, states that any Boolean expression, any Boolean expression, any Boolean function, okay, any Boolean function can be expressed, can be expressed, can be expressed in the form of can be expressed as the sum of, okay, can be expressed as the sum of product of all the variables, all the variables within the system, all the variables within the system. Okay, look here. Any Boolean function, okay, it can be expressed as the sum of product, okay, sum of product. In short, this sum of product will be called as SOP, sum of product, SOP form, of all the variables within the system, sum of product. Okay, I will take an expression xy plus yz plus, just a minute, x plus y plus z, or xy plus yz. Okay, xy plus yz, and in simple we can take it as, okay, x plus y. Okay, think this as x is also contain several products, not one product. Y is also containing several products. If we add these two, if we add these two, what will happen? It is again x plus y. It means, okay, the sum of all the products, here is also some kind of products are there, here is also some kind of products are there. It means any Boolean function can be expressed in the sum of product of all the variables. This is also a variable, this is also a variable. Think that this is also containing several products and y is also containing several products. So we have added, this means here product of many variables, here also product of many variables, then we are making it sum. Here sum means adding, that is called as sum of products. Okay, so how can we get, or how can we assign the main term? Okay, how can we assign the main term? So think that, for example, if x is equal to 0, okay, y is equal to 1, and z is equal to 0. So for these values, how can we get a min term? How can we get a min term for this? This is a simple thing. Take x as it is, okay, and see the value of x. If the value of a variable is 0, then think this as the complement of that variable. Okay, if any variable containing 0, put bar for that variable in simple. Okay, if any variable which contains 0, put bar for that variable. Okay, if a variable which contains 1, write down the variable as it is, don't put any bar. Okay, see the variable containing 0, which is equal to z. If value is 0, so we have to write bar. Just like this, we can identify a variable, or we can write down the min term of any expression. And in the same way, I will change the values for this. If x is equal to 1, y is equal to 0, and z is equal to 0. So how can we write the min term for these values? Okay, so for this x, the value of x is 1, so no need to write any bar. Any variable whose value is 1, write down the variable as it is. See the next variable, this has contained a value 0, so write down the variable and put a bar for 0. This is for min term. Okay, then z is there, write down z, value is 0, put bar. This means any variable whose value is 0. Okay, for that thing we have to write bar about that variable. Like this, we can give the simpler form of the min term. Like this, we have to create the simple form of the min term. Okay, hope you have understood this thing. Okay, now we are going to express the min terms. Okay, steps involved in min term expansion of expression. Okay, steps involved in min term expansion of expression. Okay, I'll put a line here so that you need to understand. First thing is, okay, first convert the given expression in the form of product of sum, in the sum of product form. First convert, okay, first point, first convert the given expression in the sum of product form. Okay, first convert the given expression in the sum of product form. Sum of product form means, in short, it is called as SOP form. I will take one expression here. The given expression is x plus y. The given expression is x plus y. Here I need your complete concentration so that you have to understand this one clearly. Okay, first convert the given expression in the sum of product form. How can we convert this given expression in sum of product form? Okay, first we have to see how many variables are there here. Here there are two variables, x and y. How many variables are there? Two variables. That is, one is x, another one is y. So in min term, if only one variable is there and there is no variable along with these variables, it means if there are single variables. So at that time, what we have to do, the variable required, okay, beside the variable, that thing we have to write down. Here x and y are there. So x into 1, okay, plus y into 1. If any expression which contains only single variable, okay, then we have to convert this into sum of product form, okay. Then at that time we have to multiply this by 1, x into 1 plus y into 1, okay. Hope you have understood. No single variable, okay, in short, in other form, no single variable must be contained in the min term, okay. So for any expression, if single variable is there, this means that it should contain its variable, another variable, its relative variable, okay. If x is there, then at that time this x should contain y with this, y with it. Then if only y is there, then y should also contain x beside it, okay. Here is here also xy should be present, here also xy should be present. Why? This is because only two variables are there, x and y. So each literal should contain two variables, okay. Here only two variables are there. So for this thing, okay, when two variables are present, so the rule is here is that every literal should contain the two variables here. If x is there means, then y should be present with this. Then if y is there means, then x should be present with this. So here no variables are there, just one variable x is there, here one variable y is there. So for that, we will convert to make them as two variables. We will convert into sum of product form. Just multiply the given variables with 1. Then it will become sum of product. This is the product. X into 1 is the product. Then y into 1 is the product. Multiplication will always a product. So x into 1, product of two things. Then y into 1, product of two things. Then product of one thing and product of two things. If we add, then it will become product of sum of these two products, okay. First convert the given expression in the sum of product form, okay. In each term, now you will come to know, in each term, if any variable is missing, any variable is missing, okay. If example in the following function, in the following example, x is y is missing in the first part, y is missing in the first part, and x is missing in the second part, x is missing in the second part, okay. Look here, x and y is there, okay. For min term, every term should contain at least two variables. Here xy should be present, here also xy should be present. Why? Because only x and y two variables are there. So for that, x should be present here, y should be present here, and x should be present here. In each term, if any variable is missing, here y is missing, okay, and here x is missing. Okay, example, in the following example, y is missing in the first part, y is missing here. Okay, and x is missing in the second part, x is missing here. Then after that, what we have to do? Okay, multiply that term, multiply that term, multiply that term with its factor, with its factor, with its, okay, factor. I'll write one thing here to make you understand. Missing variable or missing letter, missing term plus missing term bar, missing term, okay, bar. Missing term means plus missing term bar, which is with its factor, with its factor. It means if, okay, I'll write this here. If y is missing, if y is missing, multiply this by, multiply with y plus y bar. Okay, listen. First, convert the given expression in the sum of product form. Given expression is this. Okay, here there should not be single letter or single variable. Okay, in each term there must be two variables. One here, two values are there. Okay, two variables are there, only two. So if three variables are present, just I will say one thing: x plus y z plus x z. Okay, dear students, look at this. Here there are three variables, okay, x, y and z. So for three variable expression, three term expression, for three term expression, and there are three variables. So for that thing, every term should contain the three variables. Which are the three variables? X, y and z. Here x is there, so it should be x, y and z plus x, y, z plus x, y, z. Like this, it should be present. Okay, here see, x is there, y, z is there, then x and z is there. There are three terms, one term, two term and three term. This is the expression of three terms. So if the expression is in three terms, okay, then every term should contain all the three literals. Every term should contain all the three literals. The same way here, when two terms are there in an expression, then every term should contain two literals. That is called product of sum of product form. Okay, in each term, if any variable is missing, in each term, if any variable is missing, here y is missing, here x is missing. Okay, so multiply that term with its factors. Always multiply the term with its factor. Factor means missing term plus missing term bar. Okay, missing term plus missing term bar. Here, what is missing here? After that, y should be present. So we have to multiply this by missing term. Okay, y plus missing term bar. Y plus y bar. X into 1 is there. In place of 1, what we will do? We will take missing term plus missing term missing term bar. This is called as factor. If y is missing, multiply with y plus y bar. In simple, if y is missing, multiply with y plus y bar. Then plus, okay, y is present. If y is missing, multiply with y plus y bar. Then if x is missing, multiply with x plus x bar. X plus x bar. Like this, we have to write. After that, what we have to do? Expand the expression. Okay. The fourth thing we have to do is, third thing we have to do is expand the expression. Expand the expression. Okay. How will you expand this? First, what we did? First, convert the given expression in the sum of product form. Given expression is here. So here two terms are there in an expression. When two terms are there, so at that time, each term should contain two variables. So for that, we have converted this into product of sum of product form, SOP form. Sum of product. This is product, and this is sum. This is the sum of two products. Sum of two products. Okay, then in each term, if any variable is missing, what we have to do? Any variable is missing. Okay, multiply the term with its factor. It means if y is missing, multiply with y plus y bar. Here y is missing, so multiply with y plus y bar. In place of 1, we will take y plus y bar. Here x is missing, so for that, in place of 1, we will take x plus x bar. After that, expand the expression. How will you expand this? This is equal to. Okay, how will you expand? Same as in previous derivations. Multiply this by each term. First xy, okay, then put x. xy, then x. Here plus. Then xy bar plus, okay, x into y plus x into y bar plus y into x or x into y. Both are same. Okay, I will write as it is. X into y plus, okay, first this, then this, y into x bar. Expanding means multiplying. X into y, then plus x into y bar. Then y into x, this plus is here. So x into y first. X into y plus x into y bar. Okay, plus y into x plus, okay, y into x bar. So what we have to do? Just interchange x, y plus x, y bar plus, here y is this side, x is that side. So take x this side, x, y plus x bar. Understood? Now, the last step is, what is the last step here? The last step here is remove all the duplicate terms. Remove all the duplicate terms. Remove all the duplicate terms. We will have the mean-term form of the expression. We will have the mean-term form of the expression. Mean-term form of the expression. See, okay, I will put a line here so that you can understand. First, convert the given expression into sum of product form. If in each term, if any variable is missing, just like if y is missing or x is missing, okay, multiply that term with its factor. If y is missing, multiply with y plus y bar. If x is missing, multiply with x plus x bar. Then expand the expression. What we have to do? We have to expand the expression. How will you expand? Just multiply x into y plus x into y bar. Okay, plus y into x plus y into x bar. Expand it. So next step, what we have to do? Just interchange. Here y x bar is there. Interchange x y plus x bar. At last, remove all the duplicate terms. How many duplicate terms are here? Only x, y is duplicate here. Duplicate means if similar terms are present more than once, that type of term is called as duplicate term. Okay? If similar terms are present more than once, that is called duplicate terms. Remove the duplicate term. Just write down once x, y plus x y bar plus x bar y. So this is the derived main term expression from x plus y. Hope you have understood this. Okay, first convert the given expression into sum of product form. Then if any variable is missing, here there are two terms. So two terms are contains different variables. So condition is that the same variable should be present in each term. Okay, the same variables should be present in each term. So for that, here y is missing, here x is missing. So if anything is missing, multiply that term with its factor. Factor means y plus y bar. Here y is missing, y plus y bar. We are putting y plus y bar in place of 1. Here x is missing, then its factor is x plus x bar. Multiply this by x plus x bar. In place of 1, we are taking x plus x bar. Then expand the expression. Expand this expression. How will you expand? X into y plus x into y bar. Okay, plus y into x plus okay y into x bar. After that, just interchange. Here yx bar is there. Okay, it doesn't feel good. So for that, xy bar write down as it is. Then interchange these two things. Xy plus x bar y. Okay. After what we have to do? Remove all the duplicate terms. We will have the min term form of the expression. Duplicate things means if any expression or if any term is present in the expression more than once. Okay, if any expression is present, if any term is present in the expression more than once, that is called duplicate of terms. So here x, y are duplicate. Okay, x, y is present two times. So write down that x, y just one time. Write down that x, y just one time. Then write down x plus x, y bar. Okay, leave this one because we have already written. Removing the duplicate things. Put x here plus here, then x bar into y. This is the min term of the given expression. Like this, we have to solve the min term. Okay, expansion of min term expression. Now I will show you the second method of expansion of expression. So we will take one example. Take example as AB plus C. AB plus C. Okay. How can we get the min term of this expression? Okay. If you concentrate clearly, then only you can going to understand this thing. Okay. Firstly, the first point here is okay. This is the second method of expansion of min term expression. First method I have shown. This is second method of expansion of min term expression. First thing is write down all the terms. First thing is write down all the terms. Okay, write down all the terms, which is equal to AB plus C. Write down all the terms. Okay. Insert X. Insert X. Okay, X. Insert X wherever, okay, wherever letters must be inserted, letters must be required, inserted, letters must be inserted to convert, letters must be inserted to convert the term to a product term. I will write like this: to convert the term to sum of product form. Okay. Listen here. Okay. Write down all the terms. The terms we have written. Insert X. Okay, we have to insert X. Wherever letters must be inserted to convert the term to sum of product form. Here, three variables are there. How many variables? Three variables are there. But every term has different variables. Okay, the condition here is that every term must contain all the same variables. Every term must contain all the same variables. So three variable A, B, and C are there. So we have to make each term as three variable term. Okay. In previous example, there were only two variables. So we have made that expression into two variable term expression. Here there are three variables A, B, and C. Three are different. So we have to make every term as three variables. Every term as just like A, B, C plus A, B, C. Okay. Here A, B, then C is missing. Okay, here only C is there, A and B are missing. So in place of missing terms, we need to insert X, okay, which is equal to A, B, X plus, okay, here A and B are missing. So A, B, C. Understood? Every term should contain three variables, must and should contain, because three are the different variables. So like this, the expression should be ABC plus ABC. So for that, in place of missing variables, here C is missing, here A and B are missing. So in place of missing terms, in place of missing letters, okay, missing terms, we need to put X. So we have put X in the place of missing letters. Okay, then third point, write down the combination of X. Okay, use all the combination of X, use all the combinations of X, use all the combinations of X in each term, to generate min term, to generate min term. Okay. Listen, use all the combinations of x in each term to generate min term. In your previous derivation, what we have did, if any letter is missing, okay, if x is missing, multiply with x plus x bar. Okay, if y is missing, multiply with y plus y bar. Okay, so here in the first term, in place of x, c is missing. So what we have to do? AB into c plus c bar. AB into c plus c bar in place of x. Okay, then plus here a and b, two things are missing. Two things are missing. So first we will create. Okay, leave this one. First we will create expression for this thing. Okay, expand the expression. How will you expand? AB into C, okay, which is equal to ABC plus, okay, then second thing with this ABC bar. ABC bar. Write this as first equation. Okay, this as first equation. First part we have derived. Okay, first part is derived. Next, come to the second part. XC. Actually, AB into C. Okay, AB into C should be there. So first, what I will do, I will take firstly, I will take the last two terms. Last two terms. That is, here it should be A, here it should be B. Okay, now I will take first the last terms. Okay, B plus B bar into C. B plus B bar into C. Writing the combinations of X. B I will take first. Okay, so B plus B bar into C, which is equal to, okay, expand. Okay, C into B. Okay, which will become BC plus, okay, then C into B bar C, B bar C, BC plus B bar C. Then after that, for these two things, okay, for these two things, I will take A. For these two things, I will take A. Here, A is missing. Here also A is missing. Here also A missing. Here also A missing. So, we will do A plus A bar, okay, BC plus A plus A bar, then B bar C. A plus A bar BC plus A plus A bar B bar C. Okay. Firstly, I have took only last two things, that is B and C. B is missing, so I will take it as B plus B bar. So expand C into B, it will become BC. Okay, B into C, it will become BC. B bar C, it will become B bar C. So A is missing in every place. Here is also A missing. Here is also A missing. So I will take A plus A bar into BC. A plus A bar into B bar C. Now expand. What it will become? This is equal to first this thing. A B C plus, okay, next this A bar B C plus, okay, A B C, then A bar B C plus, then first this thing A B bar C plus, okay, next this A bar B bar C. Okay, take this as equation number 2. Okay, 1 and 2. Understood? 1 and 2. After that, what will happen? Therefore, from 1 and 2, we have to add these two, 1 and 2, which is equal to, okay, which is equal to, see, ABC plus ABC bar, ABC bar plus, okay, ABC bar plus, then second one, ABC plus A bar BC, A bar BC plus, okay, A bar BC plus A B bar C, A B bar C plus A bar B bar C plus A bar B bar C. Like this, we have to write, use all the combinations of x in each term to generate the mean term. Okay, then at last, drop out all the duplicates. Drop out all the duplicates. Okay, this is one more method. Drop out all the duplicate terms. Now what we have to do? We have to check the duplicate terms. Then we have to drop out, means we have to remove. Here ABC is there. Here ABC is there. Okay, only two things are repeated here. Only ABC is repeated twice. So there are duplicate things in that. Drop the duplicate things. Write down duplicate things just one time, which is equal to ABC, okay, plus ABC bar plus, leave this one because this is a duplicate thing. A bar BC plus, okay, AB bar C plus A bar B bar C plus A bar B bar C. So this is the min term of, okay, A B plus C. Okay, this is the min term of A B plus C. How we can do? Write down all the terms. Write down all the terms as it is. Insert x wherever letters must be inserted to convert the term to sum of product form. Okay, here three variables are there. So condition is that if three different variables are present in an expression, so every term should contain all the three variables. Here there must be ABC and here there must be ABC. So in place of missing terms, here C is missing. So I have put X here. Here A and B are missing. So I have put X. So according to our first thing, okay, here C is missing, multiply by C plus C bar. Then expand the equation. AB into C, then AB into C bar. Take this as 1. Here A and B are missing. I will take the last two terms first. Okay, B is missing, so that I will take B plus B bar into C. Multiply, it will become B into C plus B bar into C. Okay, now here A is missing in two expressions, then here is also A missing. So if we need to get this expression. This means all the three expressions like A, B, all the three variables in the term like A, B and C. So I will take A plus A bar here, then here A is missing, so I will take A plus A bar. Now expand, okay, A into BC, then ABC plus A bar into BC, A bar BC plus, okay, A into B bar C, A B bar C plus A bar into B bar C, A bar B bar C. Take this as 2. Then add these two, 1 and 2. Add 1 and 2. At the time ABC plus ABC bar plus ABC, okay, A bar BC plus A B bar C plus A bar B bar C. Then drop out all the duplicate terms. Then we have to drop out all the duplicate terms. That means we have to check any duplicate terms are there here. Here, yes, here only ABC is duplicated. The term which is present more than once in an expression is called as the duplicate term. ABC, ABC is there. Okay. Here two terms are there. It means the single term is repeated twice. So we have to write down just once ABC, then plus ABC bar plus, it is duplicate term, remove this, drop out this, then write down next term A bar BC, okay, plus AB bar C, AB bar C plus A bar B bar C, A bar B bar C. Okay. Now, is this derivation right or wrong? We have to check. This derivation is right or wrong, we have to check. Now I will, so this is the method of, okay, these are the points to convert an expression to expand an expression in min term form. Given term is expanded in min term form. So now we have to check whether this is right or wrong. So what we have to do? We have to solve this in reverse order. Okay, I will show you. Write down as it is. Okay, A B C plus, okay, B C bar, A B C bar plus, okay, A bar B C, A bar B C plus A B bar C, A B bar C plus A bar B bar C. I will try to write in one line. Okay, A B C plus A B C bar, A B C bar plus A bar B C, A bar B C plus A B bar C, A B bar C plus A bar B bar C, A bar B bar C. Okay, in this answer, okay, from this expression, we have to derive this expression. At that time, it is clear that our expansion is true. Okay, so to do this, what we have to do? Firstly, we have to take, okay, in alphabetical order. In alphabetical order, we have to take the complemented terms first. Okay, here see A bar, B bar. Okay, only one A bar, B bar is there. So I will take this one as first. A bar, B bar, C plus. Oh, okay. This is verb. Okay, if any more A bars are there, yes, here is also A bar. Okay, then take A bar, B, C. Okay, any more bars are there on A? No, there is no bar on A. Plus, we have to see any complement of B is there. Yes, complement of B is there. Take this one. A, B bar, C plus. Of that, any complement of B, any more complements of B? No, only C complement is there. After B, we have to take C complement. Okay, plus last one thing remaining, that is A, B, C. Okay, hope you have understood this thing. We have to take alphabetically complemented terms, complemented variables first. Okay, A bar, B bar, A bar, B bar. Okay, no more A bar, B bar is there, so write down that. After that, any single A bar is there, a single A bar is there, write down. Okay, after that, no A bars are there, A complements are not there. Check for B bar, any B bar is there, yes, B bar, write down that B bar, A, B bar, C. Okay, after that, any more B bars are there, no B complements. So check for C bar, yes, C bar is present, A, B, C bar. Okay, after that, any complements are present, there are no complements, write down this one as it is. Now we have to do one thing. Okay, what we have to do? Check for two terms. Check for every two terms. Check for every two terms. Okay, every two terms, whether any common thing is present in them. in first two terms, okay, a bar c and a bar c are common. In first two terms, a bar c and a bar c are common. Write down that a bar c. First term, second term. A bar is there, a bar is there. C is there, C is there. Okay, then write down B bar, okay, B bar plus B as it is. Okay, understood? Look here. We have to check every two terms whether any common thing is present. So here common thing is present. A bar C, A bar C is common, A bar C is common. So write down this A bar C. Okay, write down this A bar C. A bar C is common, A bar C is common. Write down that A bar C. Then what are the things left? Here B bar is left and B is left. So write down B bar plus B. B bar plus B. Write down plus as it is. Now check for these two things. Is there any common thing? Okay, only A is common. Okay, only A is common here. If we take only single common, that will not be more useful. So write this term as it is. A, B bar, C plus. Check these two terms. Okay, look here. In these two terms, only A is common. If we take just a single variable as common thing, then the derivation will go long. So leave this one. Check for these two things. Yes, here A, B are common. In these two terms, A, B are common. So write down A, B as it is. Then C bar plus C. Okay, C bar plus C. Is it clear? Okay, which is equal to, okay, according to complementarity laws. Okay, according to complementarity laws, x plus x bar is equal to 1. Complementarity law. So here A bar C. Okay, then B plus B bar. If x plus x bar is equal to 1, then B bar plus B is also equal to 1. Plus, write down this one, A B bar C. Okay, plus A B into, okay, if x plus x bar according to complementarity law, if x plus x bar is equal to 1, then C plus C bar is also equal to 1. Is also equal to 1. Okay, here write down A bar C into 1 is A bar C plus A B bar C plus A B. A B bar C plus A B. Now just take A B here. Two variable terms make one side. Two variables. A bar C is a two variable, A bar B is two variable. Make these things one side. Okay, which is equal to A bar C plus A B plus A B bar C. A C plus A B plus A B bar C. Okay. Then after that, write down A bar C as it is plus A bar C as it is. Any common thing is there here? We have to check again. Yes, here A is common. A is common. Write down A as it is. Then B plus B bar C. A is common here. Okay. Among these two, no common things. Okay. In first terms, there is no common thing. So write down A bar C. In second term, A, B, A are common. So write down A as it is. Then B plus B bar. Okay. According to absorption law. According to absorption law, okay, x plus x bar y is equal to x plus y. According to absorption law, x plus x bar y is equal to x plus y. So therefore, b plus b bar c is equal to b plus b. If x plus x bar y is equal to x plus y, then b plus b bar c is equal to b plus c, which is equal to a bar c plus a into, okay, b plus c, a into b plus c, a into b plus c. Okay, then next step, write down a bar c as it is plus multiply. Okay, a b, okay, a into b, then a into c, a into c, a into b, a into c. Then take ac this side, which is equal to ac plus a bar c plus ab. Okay, just change the position. Take ac at first, then this side a bar c, then a plus b. Among these, any common thing is there? Yes, c is there. C into a plus a bar plus ab. Okay, according to complementarity law, x plus x bar is equal to 1, then a plus a bar is also equal to 1, which is equal to c into 1 plus ab, okay, which is equal to c plus ab, at last ab plus c. So by all these things, okay, I think you're not looking here, so I'll write these two steps this side. Okay, see here, a plus a bar, okay, according to complementarity law, x plus x bar is equal to 1, then a plus a bar is also equal to 1. So for that, c into 1, c into 1 plus ab, which is equal to, okay, c plus ab, okay, that is equal to ab plus c. So finally, we have got the result as ab plus c. Look here, from ab plus c, we have derived this expression, expanded. And from this expression, we have again derived ab plus c. So this means our expansion of an expression is true. Okay, our expansion of an expression is true. I will explain one more time. Okay, write down these things as it is. Then check for alphabetical things first. In that, complement things make one side. Okay, a bar, b bar, c, both are there. Keep first. Then check for more a bars. If any a bar is there, okay, here a bar is there, so a bar, b, c. Two are over. This one is completed, this one is completed. Then no more a bars are there. Check for b bar. Any b bar is there? Yes, b bar is there. Only one b bar. Write down that one. Okay. If any more b bars are there, no b bars are there. Only c bar is there. Write down the c bar. Okay. If any more c bar, no c bar. Only one term is present. Write down the last term. Okay. After that, check every two terms. Any common thing is there? Yes, here a bar c and a bar c is common. So take a bar c outside the bracket, then write down b bar plus b. Okay, plus in these two terms, only one letter is common, one variable is common. If you take one variable common, the expansion will go long. So leave this, check these two things. Any two letters are common? Yes, A, B are common. So write down as it is, A, B are common. So write down A, B, then write down C bar plus C as it is. According to complementarity law, X plus X bar is equal to 1. So A bar C, then if x plus x bar is equal to 1, then b plus b bar is also equal to 1. Plus, write down this one as it is. Here c plus c bar, according to complementarity law, if x plus x bar is equal to 1, then c plus c bar is also equal to 1. After that, multiply these things. A bar c into 1 is a bar c, plus write down like this. AB into 1 is AB. Make similar terms, two term, okay, two variable term, one side. Write down A bar C, then A bar B, after that E. Sorry, write down A bar C, then AB, then A B bar C. After that, look any common things here. In these two terms, there is no common thing. Check for common things in next two things. Yes, here one common thing is there, that is A. So write down A, then this A is here, A is here. So it will become B plus B bar C, B plus B bar C. Then according to absorption law, X plus X bar Y is equal to X plus Y. So for this thing here, B plus B bar C will also become B plus C. So write down A bar C as it is, then A into it will become B plus C according to absorption law. Then expand, multiply. Okay, write down A bar C plus AB, then plus, okay, AC. Okay, then write down, just interchange. Take AC this side, AC come this side, plus write down A bar C plus AB. Okay, in these two things anything is common? Yes, C is common among these two. Take C outside, then write down A plus A bar. Okay, then plus AB. Okay, according to complementarity laws, x plus x bar is equal to 1, so therefore a plus a bar is also equal to 1. Then c into 1 plus ab. So by this c plus ab. Okay, c into 1 is c, plus is plus, ab is ab. Okay, just change the order of the terms, then it will become AB plus C. Like this, we have got the result of this expansion. By all means, this is true. So, dear students, one more thing that is called as shorthand notation of midterm. So, we shall discuss in our next class the shorthand midterm distance, shorthand midterm derivation, and also with max term and also the derivation of max terms. One thing you need to remember is in mean term there is always SOP form. It means sum of product. Okay. When we move to max term, we'll come to know what are the form there. If you have any doubts regarding this, you can ask me. Thank you.